Next problem we will deal with is now the discriminant is so this is of parabolic type, and the characteristic equation then can be found out as point 1 that only one equation will be there, and that is this. So integrating we have so what we see that the second one needed to be found out, and to do that what we do that we take say eta is equal to y simply, and with the help of this we see a bar is equal to 0, b bar is equal to 0, c bar is equal to cos square x, d bar equal to 1, e bar is equal to 0, f bar equal to 0. Hence we find out the equation as cos square x u eta eta plus u xi is equal to x. And simplifying we have replaced x so after replacing this x and this cos square x we have this relation, and this is completely with respect to xylem and eta. Next problem where this n and a, these are two constants. So what we do we observe that a is equal to 1, b equal to 0, c equal to minus 1 over square, d equal to 2n over x, and e, f, g all are vanishing, so b square minus 4ac is equal to 4 over a square, which is of course a positive quantity. Hence this given equation is hyperbolic, and as this is hyperbolic, what we will do, we will at first find out the characteristic, and that is minus plus 1 over a, and solving we have dy dx is equal to either minus 1 over a or dy dx is plus 1 over a. So we have y is equal to minus x over a c1, that is y plus x over a is equal to xylem xy, and y is equal to x over a plus c2, that is y minus eta xy. These two are two characteristic equations, and now we will solve that, and please check, I'm not going through the detailed calculation, that this should be your canonically transformed equation. After canonical transformation, the equation becomes this. Please check.